In algebra, we learn how to manipulate expressions. Now I'm going to go ahead and manipulate these expressions here, and then we'll discuss what was the result and what was the point of that. So the first one, 7x add 2x, we know that that actually simplifies to 9x. Now notice how I said simplifies this time. So I've changed this expression. It's still an equivalent expression on this side, and it's 9x, and that's simplified. So we can see why we might have done that. 7x add 2x, it's a little bit longer to write. 9x is just simplified there. This expression here, what I'm going to do with that is I'm going to expand. So I'm going to expand this or multiply it out, and I know what happens is I multiply the 3 by the x and multiply the 3 by the positive 2 there. So 3 times x is 3x, and 3 times 2 is 6, so I need to add 6 to that. So what I've done here is, this is the expression that I started with. I've got an equivalent expression on this side, but you might be asking, oh well, why did we do this? Doesn't really look too much more simpler than that, and what was the point? Now I've actually got the same expression here, and sometimes we're going to be asked to factorize this. So factorize this would look like this. So the answer when I factorize it is going to be 3 and then x plus 2. Now you might think, okay, sometimes I'm given this and I need to expand it, and sometimes I'm given this and I need to factorize it. Now what's the point of all of this? We understood what the point of this one was. We simplified it, and it looks much more simple on this side. But what was the point of expanding and then factorizing? Why am I doing this? Why am I asked to do this? Now for the rest of this video, I'm going to be talking about factorizing, and one basic reason that we're taught early on in algebra about why factorizing is useful to us. So have a look at these, and we're going to be looking at factorizing. Now here's the same expression we expanded out last time. I'm just going to show you a different way of coming to the expanded result. What we have here is 3 times x plus 2, or we can say 3 lots of x plus 2. Now when I say 3 lots of x plus 2, that means to me I'm going to have x plus 2, add another x plus 2, and add another x plus 2. Now I'm going to write it out like that. So I'm going to say, well, this means x plus 2, add another x plus 2, and then add another x plus 2. Now I know when I have addition, what I can do is I can move these around and it remains equivalent, which is the commutative law. So what we can say is x add x add x add 2 add 2 add 2 is the same as the expression that I had above. Okay, now x add x add x, well that's just 3x. 2 add 2 add 2, that's 6. So this then simplifies to 3x add 6. Now think about how we got this time. Last time we said 3 times x and 3 times 2. This time we're saying 3 lots of x plus 2, and that's what we've written here. Then we moved it around because when we have addition we can do this. Okay, we can say x plus x plus x add 2 add 2 add 2, and that'll be the same as above. And then we know when we simplify x add x add x, it comes as 3x, and the 3 2's here gives us 6. So notice how we got 3 x's here and we've got 3 2's here. This always works like this. Now we can also see that, well, if I was to factorize this, I've got 3 lots of x and I've also got 3 lots of 2, which gave me the 6. So if I was to factorize the expression 3x add 6, this gives me 3 lots of x add 2, and I can see that here. It's 3 lots of x and it's 3 lots of 2. Now here again, you might be thinking, well, why might we do this? Okay, sometimes, we're expanding this to get that, and sometimes we factorize to get this. Now notice how when it's in factorized form, what we have is a multiplication. Okay, factorizing is writing a multiplication that gives us the result, which is this. And expanding here was just, well, we'll multiply this out and see what you get. But factorizing is specifically writing a multiplication, and here we've got 3 times x plus 2. So why can that be useful? Now one of the things that we're taught quite early is that This can be useful when we are simplifying fractions. Now I'm just going to show you an example with numbers first. So for example, if we had 4/8. Now, well, 4/8 can also be said as 3 add 1 over 7 add 1. Now, here you might be thinking, okay, why might I do this? Well, there's no real reason why we should do this, but this is just an example to show you what can happen. Now, 4/8 and 3 add 1 over 7 add 1, they are equivalent. Now, one thing that people make mistakes with early on is they look at expressions like this and they think that there's a 1 here and that will cancel with that 1. Now here you're actually forgetting that fractions don't simplify like that. Fractions simplify when you either multiply or divide the top and bottom number by the same thing. Simplifying these ones here doesn't do that. You can see that 4/8 is not equal to 3 over 7. It's not equal. So it won't be equal to 4/8 is not equal to 3 over 7, and it never will be. But what we can do is, suppose here we wrote the 4/8 as an addition at the top and an addition at the bottom. Suppose we wrote it as a multiplication. Watch what happens now. So let's say 4/8 is equal to, let's start by saying 2 times 2 over 2 times 4. Now we can see that, well, if I was to divide this top by 2, so I got 2 times 2, divide that by 2, I lose a 2. Here I got 2 times 4, divide that by 2, I lose a 2. Now notice how I divided the top and the bottom by 2, and that's how these 2's will actually cancel. So these will cancel and it will leave me with 2 over 4. Now 2 over 4 is an equivalent fraction to 4 over 8. 4 over 8 is a half. 2 over 4 is a half as well. We could have also said 4 over 8 is equal to 1 times 4 over 2 times 4. So here we got 4 over 8. Well, 4 is 1 times 4. 8 is 2 times 4. This time we can see clearly that if we were to divide the top by 4 and the bottom by 4, we get the result a half. Okay, so here we can see that these 4's cancel and 4 over 8 is actually equal to a half. Now compare this and this to this one. This does not work. 4/8 is not 3 over 7. Whenever you have an addition like this, they do not simplify. Here, when we write it as factors, so 4, here we've actually factorized 4 and said 2 times 2 is 4. Here also 2 times 4 is 8. Here we've got 1 times 4, here we've got 2 times 4. Now, the reason why we don't use the word factorize here so much is because it's not in algebra, and factorize is a word that we normally use for algebra. So how do we get this expression rewritten as a multiplication? So here we've got 3 times x plus 2. And here we've got actually 3x add 6. So think about this. Okay, this is the reason why we will factorize. We're going to be factorizing to simplify fractions. This is one of the early uses of factorize that we learn. Now let's look at how this is going to work with algebra. So if I had 3x add 6 over 6. Now how would that simplify? Now, here I've got 3x add 6, and here I've got a 6. This 6 and this 6 will not cancel out, because here I've got an addition. 3x add 6 is similar to this. We can say 3 add 1, we've got something add something. Here we could have said 0 add 6, and they just don't cancel like that. But here I can see that I've written this as a multiplication, and then they cancel, because when I've written it as a multiplication, it's clear to see that when I divide by 2 to the top and bottom, these cancel. Here, when I divide by 4 for the top and the bottom, they cancel. So I'm going to rewrite my expression here as multiplications. So what we can say is, well, the top is, we can see already, is going to be 3x plus 2, because we have that. And the 6 at the bottom, I'm just going to say that's going to be 3 times 2. So the 6 is 3 times 2, okay? And the 3x plus 6 is 3 lots of x plus 2, which we have here. So now I've got the top written as a multiplication, 3 times x plus 2, and here I've got 3 times 2. So if I divide by 3 at the top, this 3 will cancel, and divide the bottom by 3, this 3 will cancel. So then my answer, when I simplify it, it would be x plus 2 is left at the top, and a 2 at the bottom. Now again, don't get tempted to think that these simplify. They won't simplify because this x had 2 and this is 2. Okay, you need to have a multiplication like we have here, then they simplify. Now I'm going to skip to some complicated factorizing, but I'm going to compare it to these examples above so that you can see how these are really quite similar. So the first one here, I've got 7 times 3 take away 6 times 3. Well, that's 7 lots of 3 take away 6 lots of 3. I can see that that's going to be only 1 lot of 3 because I've got 7 lots of 3 there. If I subtract 6 lots of 3, I'm left with just 3. The other way I can look at it is, well, 3 is a factor of this bit here, and 3 is a factor of this part here as well. So therefore the 3 will factorize. And if the 3 factorizes, we can say, well, that becomes 3, 7 take away 6 like that. So that's one way we can look at it as well. And then we know 7 take away 6 is 1. This then becomes 3. The other way to look at it, like I said, 7 times 3. I've got 7 lots of 3. Subtract from that 6 lots of 3. Well, I'm just left with 1 lot of 3. So I could have just said 1 times 3 just to begin with. Okay, and then that will be 3. The next one here, this time instead of the 3, I've got an A. And here, instead of the 3, I've got an A. Everything else pretty much stays the same. So 7 times A, or 7 lots of A, take away 6 times A, or 6 lots of A. Well, we know 7A take away 6A is just A. How we had just a 3 at the end, here we're just going to have A at the end. We could have also said that the A factorizes, because A is a factor of this expression 7A. A is also a factor of this expression 6A. And A could have factorized, and I could have written it like this, with A, and then in brackets 7 take away 6. But I'm not going to do that. I'm just going to say, well, 7A take away 6A is just A. Now the next one, this is where it's getting a bit more complicated. I still have the 7, and I'm multiplying it to something. I've got 2x take away 3. But this something that I'm multiplying it to, I've got it here as well. So I've got the subtraction, I've got the 6, and 6 times whatever I'm multiplying the 7 to here. So I've got 7 lots of 2x take away 3, take away 6 lots of 2x take away 3. Well, that will just leave me with 1 lot of 2x take away 3. I'm just going to show you how this bit is sort of staying the same in these expressions. Okay, and this is in the same position, and the rest of it is staying the same. Okay, so I've got 7 lots of something. Here I had 7 lots of A. I'm taking away 6 lots of something. Here I had take away 6 lots of A. And this thing that I'm taking away is the same in both places. So I'm left with just 1 lot of 2x take away 3. So this can be 2x take away 3. Now times by 1, I don't need to write that. We don't normally write that. Now I could have also said that the 2x take away 3 factorizes, like I said here, because 2x take away 3 is a factor of this expression here I have. So 7 times 2x take away 3. 2x take away 3 is a factor of this expression. It's also a factor of this expression, so it would have factorized. Now this is where I'm going to actually show you how that works, because then I need to compare it to this one where it becomes a bit different. Here I've got 2 lots of x plus 5. And add to that 3 lots of x plus 5. Well, you might say, well, 2 lots of something, add 3 lots of something is just 5 lots of that. So that's one way we could have simplified it. We can say that's just 5 lots of x plus 5. Okay, so have a look at this again. So 2 lots of x plus 5, add 3 lots of x plus 5. Well, if I had 2 lots of something, add 3 lots of the same thing, it should be 5 lots of that thing. Now also we can say x plus 5 is a factor of this expression that I have here, 2 times x plus 5. X plus 5 is also a factor of this expression that I have here, which is 3 times x plus 5. So x plus 5 can factorize here, like we factorized that 3 there. So here I could say that x plus 5 factorizes, and then I need to multiply the x plus 5 by 2, and I need to multiply the x plus 5 by 3. So I need to do 2 add 3 here. Now notice how the x plus 5 would multiply to the 2, the x plus 5 would multiply to the 3. That's what I'm looking at here. Now 2 add 3 is just 5. So this is just 5 lots of x plus 5 as I have above there. So it's going to be 5 times x plus 5. Okay. Now you might be thinking, okay, what was the point of doing this? Well, there isn't a point, but there is a point of doing this for this video and for the next example, so that you can see some similarity from here to here. Now this time we've got the x plus 5 here, we've got the x plus 5 here as well. The 3 is still there, but instead of a 2 I've got 2x. Now this is where this becomes more useful, something like this. Because here we could have said, well, I've got 2 lots of something, add 3 lots of something, that's 5 lots of something. If I say I've got 2x lots of something, add 3 lots of something, well, 2x and 3, they don't simplify together. Here the 2 and the 3, they added together to make 5. 2x and 3, they don't add together to simplify to anything, but we can say 2x add 3. Okay, so we've got 2x add 3 lots of x plus 5. That's one way to look at it. So we can say that this expression, I'll write it here, is 2x add 3 lots of x plus 5. Okay, that's one way to look at it. The other way to look at it would be to say, okay, x plus 5 is a factor of this expression here, where I have 2x times x plus 5. And x plus 5 is also a factor of this expression here, where I have x plus 5 times 3. Now, that means that x plus 5 will factorize. So x plus 5, what I have is, I have x plus 5, and I'm multiplying my x plus 5 to 2x. Okay, so I'm going to write the 2x here. And I'm also multiplying my x plus 5 to the 3. So I need to say add 3. Now, if you look at it here, I've got x plus 5 times 2x and x plus 5 times 3. Both of these expressions are equivalent as well. Okay, so think about how we got each of these, okay, and really try spend some time thinking about it, and this will really help you. Now here are some questions for you to practice. I've said factorize or simplify. Some of these would mean you simplify, some of these would mean that you factorize, and it does get quite complicated at the bottom. Think quite hard about how these ones work at the bottom and answer them, and you can come and check them with me.